Dear all, we'll continue with the fundamentals of counting and problems that are related to fundamentals of counting. So this is permutation with alike things, which is very important. So we know that the number of permutations of n things which are taken all at a time is npn, and which is represented as p of nn, which is equal to n factorial. Suppose out of these n things, n1 is of type 1, n2 is of type 2, similarly nr is of type r, such that n1, n2 up to nr is equal to n. Okay. In such cases, the number of permutations of n things by taking all the things at a given time is given by n factorial divided by n factorial n1 factorial into n2 factorial up to nr factorial. So now we will see one problem based on this particular formula. Find the number of permutations of the letter of the following words. So now the word is mathematics. So in the given previous problem, n is the total number of letters which are present in this particular word. So if you look at this number of word letters present here is n is equal to 11, out of which m is of type 1, that is m is one letter, which is two letters are there in this. Similarly, I have a which is of 2, another a is equal to 2. T is also, you have two letters, then other things H, E, S, I, C is equal to 1. So with this m1 for m I will write n1 which is equal to 2, n2 is equal to 2, okay, and n3 is equal to 2, n4 is equal to 1, n5, 6, 7, 8. So this is for H, E, S, I, C. So if you add all these letters, that will be 11. So with this, the number of permutations which is given by the general formula is n factorial divided by n1 factorial in dot n2 factorial up to nr factorial. If I apply here, so 8 factorial divided by this 2 factorial, this 2 factorial, this 3 factorial, and the remaining all are 1 factorial into 1 factorial into 1 factorial into 1 factorial into 1 factorial. If you find this value, what you are going to get. Okay, so sorry, this is 11 factorial, this is 11 factorial, so that you are going to get it 11 factorial divided by 8. Okay, so that is 49, 89, 600 is the value. We'll see other problem of similar kind, topology. So where n is equal to 8 here in this particular problem. So if you find here O is appearing 3 times, so I will take it as 3, and all other letters will be 1. So if you add all this, so 1, 2, 3, 4, 5, this 5 plus 3, that is 8. So total number of letters will be 8. So now n1 is equal to 3 as I did earlier. N1, this is n3, this is en4, this is en5, and last one is en6. Okay, I have written n1 plus n2 plus n3 plus n4 plus n5 plus n6 is equal to 8. So with this, the required number of permutations is given by 8 factorial divided by 3 factorial into 1 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 factorial. So which is equal to this value 6720 will be the total number of permutations. Okay, another problem. The letter is engineering. If you look at this particular problem, it contains 11 letters. Okay, so 3, 6, 8 and 11. So out of which E is appearing thrice, E is equal to 3. Same thing, N is equal to 3, I is equal to 2, G is equal to 2, R is equal to 1. So N1 is equal to 3, N2 is equal to 3, N3 is equal to 2, N4 is equal to 2, N5 is equal to say 2. So if you add all these letters, it will be 11, and the formula will be n factorial, that is n is n factorial divided by, so n1 factorial, n2 factorial, n3 factorial, n4 factorial and n5 factorial. So which is this value. If you find the value, it will be 277,200. Okay, this is a very important problem where certain conditions are given in order to find out the number of permutations. Find the number of permutations in each case. Okay, so all the E's in a given letter, so whichever all this 3E are together, that is all these three should be in one place and other rest all letters will be in some other place. Then G and R next to each other, so it can be GR, RG, whatever it is. So G and R next to each other, all the vowels are adjacent. So in this the letters are E, vowels are E, I, E, E, I. That is 3 E's and 2 I's are at adjacent side, and all the arrangements begin with N. So there are 2 letters N and N. All these arrangements should begin with N. So this is the particular problem which we need to find out the number of permutations in all these 3 different cases. Okay, we'll solve one by one. The word engineering has 11 different letters, that is N is equal to 11, with E is equal to 3, N is equal to 3, I is equal to 2, G is equal to 2, R is equal to 1. So when all E's are written together, put together, I will treat this as one single letter. If you look at here, I have written all these 3 as a single letter, so that is why I have taken here N is equal to 1. Then remaining letters N and I, all G's are put together, 3 plus 3, 6 plus 2, so that is 8. Now the total number of letters is equal to 9. So this is of one type, this is of other type. Okay, that is all 3 N remaining letters. N is equal to 3, G is equal to 2, R is equal to 1 and I is equal to 2. So hence I can write it as 9 factorial divided by 1 factorial into 3 factorial into 2 factorial into 2 factorial into 1 factorial. So which is equal to this one divided by 24, which is equal to 15120. So next is when G and R are next to each other. So when I take G and R together, I will consider that as a single letter. So remaining with 3 letters of E, N is 3 and I is equal to 2 in given engineering word. So with this, N is equal to 1, I'll take 1 plus this 3 plus 3 plus 2, which is equal to 8. So now the total number of letters will be 9. If we find the permutations now, the total number of associated permutations will be this 9 factorial divided by 3 factorial into 3 factorial into 2 factorial into 1 factorial. So which is equal to 5040. Okay. So this is one for the G and R put together I have taken. So now there are two G's and one R given in the given word. So that this possibilities of appearing in G and R will be GRG, RGG, GGR. So this is the possibility. If you calculate this one, you will get the same letters, that is 5040. For this also, if you put together RGG as one letter, so again remaining also you will get uh, one thing, and other one GGR also you are going to get. But the total number of combination will be this plus this plus this. If you add all these three, so for this also you will get this one. If you calculate for RGG also you will get this one, and GGR also you are going to get this one. So the total number of permutations required will be 5040 into 3. So that is, this is the value 15120 when G and R are next to each other. So another one is when the all the vowels are adjacent. If you look at the English, we have A, E, I, O, U are the different vowels. But here in the given word, I have E and I have I are the two different vowels, and I have to these two letters should appear adjacent, so that I can take that one as a single letter. So if I write that triple E and I, because all E's and I's together, remaining is this one. So remaining letters will be this one. So I can write this as 1 and this as say 6. So totally I have 6 plus 1, 7 factorial divided by this. I will take it as 1 factorial. Then I have n is equal to 3, g is equal to 2, r is equal to 1, and this is 1 factorial for this particular letter when I have taken put together. So this equal to, if you calculate the value, you are going to get this value, okay, which is equal to 420. So this 420, if you find out for this particular option, but if you look at, there are 3 E's and 2 I's. Inside 3 this one only, I have 3 E's and I. How can I arrange this inside? Okay, if you look at I is one, this is one letter, this is of type 2 letters. Inside this, I can arrange 5 factorial divided by 3 factorial into 2 factorial. So this is when I have considered all, but inside again I have multiple number of E's and I's. So this will be 10 different ways. This itself can be arranged in a 10 different ways, but put together is 100, again 100 and 420. So the total number of permutations will be this and this, that is 420 into 10, that is 4200 ways, or the required number of permutations where I and all the vowels in the given letter are adjacent. Okay, the last one is arrangements that will begin with N. So if you look at there are 11 letters in the given word. If I begin with one letter n, so I left out with 10 other letters. So we have, for those 10 I have this is the option. So 1 2 plus 2 plus 1, and this is C2. The number of required uh, permutations will be 10 factorial divided by, okay, so 2 factorial into 2 factorial into 1 factorial into 2 factorial. So this is what the options will be, because the number of e will be this is 3, so this will be 3. So engineering, engineer, so this will be 3, so that is why I have taken it as 3 factorial. If you find out this value, you are going to get 75,600, which is the particular value. Because n I have taken 2, because there are 3 different letters, so out of which I already have taken 1 in the beginning, so left out with 2 letters, so that is why I have taken it as 2 letters. Okay, we will continue with one more problem. Find the number of permutations of the letter uh, of the word Mississippi. In how many ways these begin with the letter I, begin and end with S, and has all I's together? So if you look at this particular word Mississippi, which contains 11 letters, okay, so I can call it as n is equal to 11. When you count the number of letters here, so m is equal to 1, and I, this is 1, this is 2, this is 3, and one more is here, so I is equal to 4, and S is also 4, and I is also 2, that is P is also 2. So this is what the count: m is equal to 1, I is equal to 4, S is equal to 4, P is equal to 2. Now with this, the total number of required permutations is equal to total n is equal to 11, that is 11 factorial, divided by m is equal to 1, so 1 factorial, so remaining is 4 factorial into 4 factorial into 2 factorial. If you find these values, you are going to get 34,650, which is the value. Now there are 3 different conditions. One is beginning with the letter I. So if you look at the total letter contains is 11 in a given word. Now we have left out with 10 blanks spaces for filling others, because the first letter is always I. So remaining letters will be how much? 10. So this possibility of the permutations is 10, okay, 10 factorial divided by, so m is equal to 1. So I is equal to, we have actually 4 letters, 4 i's, so out of which one is starting with I, so remaining is 3 letters, that is 3 factorial, into s factor, that is s is equal to 4, that is 4 factorial, and this is p is equal to 2, that is also 2 factorial. So if you calculate this, you are going to get 12,600 value. So next is begin and end with S. So if you look at beginning with one letter, that is S, ending with S, so this will be permanent. So now in between you have 9 different characters or letters you can add. So that is why M is equal to 1, S is equal to 4 minus 2, that is 2 options, I is equal to 4, and P is equal to 2. With this, I have an option of finding out the number of required permutations is equal to 9 factorial divided by this 1 factorial into 4 factorial into 2 factorial into 2 factorial, so which is equal to 3780. But if you look at the yes, in the given letter it is 4. That is 2 times I can take it out. So once for one set it is yes, yes, second set yes, yes. If you find for second pair of s, again you are going to get it as 3780. So hence I am going to multiply by 2 in order to get the total required number of permutations as 3780 into 7500 is equal to 7560. So another last option is has all i's together. So for all four i's will be treated as a particular single letter. If you look at these four i's, then left out with m, then remaining 4s and p. So this is 1 and rest all will be 7. So you are going to get n is equal to 8. Now the required number of permutations is equal to this 8 factorial divided by 1 factorial, then 1 factorial for m, 4 factorial for s, and 2 factorial for this last one is that is p. So hence you are going to get this as 840. So this is how we are going to solve these particular problems. Okay. Another interesting problem is how many number of positive integers n we can form using all the digits 3, 4, 4, 5, 5, 6, 7 if we want n to exceed this 50 lakhs. Okay, so how many number of such the combinations we will have? So if you look at there are 7 digits. Okay, there are 7 digits like 3, 4, 4, 5, 5, 6 and 7. So I will call this a number which contains 7 digits. I'll write it as D1, D2, D3, D4, D5, D6, D7. Okay, where Di being digits. If n has to exceed this value, which has also 7 digits, so which contains 7 digits. So if you write the different combinations of these letters, if you want a number which is to exceed this value, is like the number should always the begin with this either 5 or 6 or 7. That is the first letter. Okay, rest all is any combination of other numbers. Okay, now I'll take case 1 where the number starts with 5. So there are 5 is the first condition, d1 is equal to 5, and rest of the 6 digits has to be two numbers of 4 and one each of 3, 5, 6, 7 in the given list. So if you write down the number of such permutations will be 6 factorial divided by 2 factorial into 1 factorial into 1 factorial into 1 factorial into 1 factorial, which will give you 360. Similarly, if you write down next one with the case 2, if the number starts with 6, the rest of all digits should be like two numbers should be 4, two numbers will be of 5, and one each of 3 and 7 in the given list. So if you write down, it will be 6 factorial divided by 2 factorial into 2 factorial into 1 factorial into 1 factorial. Again, it will give you 180. So this is with respect to case 2. When you write case 3, when you write down D1 is equal to 7, as in the previous two steps, the 6 digits has to be like 2 of 4, 2 of 5, and 1 is of 3 and 6. If you write down this, the number of permutations here will be this 6 factorial divided by 2 factorial into 2 factorial into 1 factorial into 1 factorial. So again that will give you 180. So all these three cases are correct. All these cases are all to get the number which is more than the required value. So by applying sum rule, the required number of n's, okay, exceeding this is sum of all this. So hence the required n will be 360 for case 1, 180 for case 2, again remaining 180 will be for third case. So the total number of required options or required combination permutations will be like 720. So this is how we are going to solve some of the problems on this particular value. Okay. Next is binomial theorem. If n is an positive integer, then expansion of x plus y to the power of n in the following form is called as a binomial theorem. Okay, we'll see how it is. So x plus y to the power of n is equal to x to the power of n plus nc1 into x to the power of n minus 2 plus nc2 dot into x to the power of n minus 2 y square dot ncr plus x to the power of n minus r into y to the power of r plus y to the power of n. I'll call this as equation 1. So here, so x to the power of n, actually I have to write like this: nc0 x to the power of n minus 0 plus y to the power of 0, and after that this nc1 plus x to the power of n minus 1 y to the power of 1. So that is where it started with nc0 x to the power of n minus 0. So if it is 0, then it is n minus 0, then it is y to the power of 0. If it is 1, x to the power of n minus 1, and it is y to the power of n. Similarly, if it is 2, then n to the power of minus 2, then y square. Similarly, here I have written it as r as n to the power of r, y to the power of r, and here y to the power of n, I can write it as ncn. So it is x to the power of n minus 1 and y to the power of n. So if you look at ncn is 1, x to the power of n minus 1, that is 0. So again it will be 1 into y to the power of 1, which is y to the power of 1. So here also nc0 is 1, then x to the power of n minus 0 is x to the power of n, which is here, and y to the power of 0 is 1. So if you look at, there are n plus 1 terms in the particular expansion, and the general form for this particular expansion is represented by t of r plus 1. If you look at the general form, I can write it as t of r plus 1 is equal to ncr x to the power of n minus r into y to the power of r. So this I can write it as ncr x to the power of r into y to the power of n minus r, which is equivalent to this. Now x plus y to the power of n, which I can write it as this one from the given equation 1, that is in the summation form. Summation of r is equal to 0 to n ncr is ncr x to the power of n minus r into y to the power of r. So which is again equal to, so ncr x to the power of r into y to the power of n minus r. Okay, with this particular formula. So I will call this as equation number 3. Okay, this is what we have seen the previous the form of binomial theorem. So in general, if we have many terms like x1 plus x2 plus x3 up to xr plus xr to the power of n, where these all n1, n2, n3 and n to nr are all non-negative integers, and these are all less than or equal to n. So n1 plus n2 plus nr, then the coefficient of x1 to the power of n1, x2 to the power of n2 up to xr to the power of nr is given by this one. This is very important. That is n factorial divided by n minus n1 factorial into n2 factorial into n2 factorial, and which is denoted by this. So in a given expansion, when you are using binomial theorem, the coefficients of the different terms will be given by this particular formula. That is n, this is nothing but n divided by n1 factorial divided by, sorry, n factorial divided by n1 factorial into n2 factorial up to nr factorial. Okay, so in general I can write it as the general binomial theorem, which is x1 plus x2 plus x3 up to xr to the power of n, which is equal to sigma, because it is many terms, sigma of x n1 into n1 into nr, so into x to the power of n1, x to the power of n2 up to xr to the power of nr, where the summation is over all nr of nr. Okay, so this is how we are going to write down the general form of binomial theorem. We will solve some of the problems which are related to binomial theorems. Look at here. Find the coefficients of a to the power of 5 b square in the expansion of 2 into 2a minus 3b whole square whole to the power of 7, and the second one is x6 and y cube in the expansion of x plus 2y to the power of 9. So this is what we need to find out. So we'll see how it is. So we know that there are only two different coefficients, so I can write it as x plus y to the power of n is equal to this formula. So which is my given formula, that is sigma r is equal to 0 to n ncr x to the power of n minus r into y to the power of r, or x equal to r is equal to 0 to n ncr x to the power of r into y to the power of n minus r. Okay, if you apply this particular formulas, 2a minus 3b whole to the power of 7 is equal to this one, r is equal to 0 to 7. So n is equal to 7, r we need to find out. What would be the value? 7cr into 2a into x to the power of 7 minus r, okay, as per the given formula, into minus 3b to the power of r. This I can write it as 2a minus 3b whole to the power of 7 equal to r is equal to 0 to 7 n 7cr. So I will expand this 2 into 7 minus r, okay, 7 minus r, then minus 3 to the power of r into 2a again into 7 to the power of 7 minus a to the power of 7 minus r into b to the power of r. So which is my given formula. So here, so minus 3r, no? So 3r to the power of r, then r to the b to the power of 7r, and here also 2 to the power of 7 minus r, a into 3 to the power of a into 7 to the power of 7 minus r. So with this, So in order to find out the coefficient as a to the power of 5, to get that I need to substitute this r is equal to 2 only. So by taking the value of r is equal to 2 here, I am getting this one. So r is equal to 0 to 7, 7c2. This I will substitute r is equal to 2. When you substitute r is equal to 2, the except this part, the coefficient will be 7c2, okay, into 2 to the power of 5 minus 3 whole square, this one. So this, if you substitute this value, if you find this value, 6048 will be the value, and which is coefficient of this a to the power of 5 into b square. So this is how we are going to find out the coefficient of. Okay, the next second one is x to the power of 6 y cube in the expansion of this. So you know this particular formula, which is equation number 6, x plus y to the power of n is equal to 0 to n ncr x to the power of n minus r y square yr is equal to r is equal to 0 to n ncr x to the power of r into y to the power of n minus r. Now like we did in the previous problem, so I will take n is equal to 9, so n is equal to 9, r is equal to 0, then 9cr, then x to the power of n minus r, that is why x to the power of 9 minus r into y to the power of r, where y is equal to 2y, so that is why I have written 2y to the power of r. So in order to get x to the power of 6 and y to the power of 3 at this right hand side, I need to select r is equal to 3. Okay, if I select r is equal to 3, then we have x plus 2y to the power of 9 equal c3. Okay, then x to the power of 6, then 2y to the power of 3. So which is x plus y to the power of 9, r is equal to 0 to 9, then nc3 you see here 2y whole cube, that is 2 to the power of 3 into y to the power of 3. So that is what I have written, 2 to the power of 3 into y to the power of 3, and this x to the power of 6. So the coefficient of this is the remaining part of this, that is 9c3 into 2 to the power of 3. So 2 to the power of 3 is 8, so 9c3. So 9c3 you are going to get this one into 8, which is equal to 678. So sorry, 672, so which is your value. So now the coefficient of this is equal to this is the value 672. So other problem which is of the type where x plus y plus x1 plus x2 plus x3 up to xn to the power of n. So find the coefficient of x square plus y square x square y square z cube in this particular expansion, x plus y plus z to the power of 7, and also find the sum of all coefficients. So the general term here, what we have seen in the previous slides, is that general term is given by this one, n by n1 n2 n3, then x to the power of n1 n y to the power of n2 z to the power of n3, where n1 plus n2 n1 n2 n3, if you add all these three, that should be n1. So that is where, if you look at here, so n1 is 2, n2 is 2, n3 is 3. So if you add here, so 2 plus 2 plus 3, which is equal to 7, and this 7 to the power of n, which is same. Okay, so then I can apply this particular formula. So now what I have done is n1 n2 n3, so 7 divided by this one, 7 2 then 3. So x to the power of n1 y to the power of n2, z to the power of n3. So the coefficient of this is given by 7 factorial divided by 2 factorial into 2 factorial into 3 factorial. Okay, if you do this, 7 factorial divided by this value, so which you are going to get it as 210. So the values, the coefficient of this will be 210. Sum of all coefficients in the given expansion. If you look at the given problem, it is x, y, z, and here the coefficients of this is what? Coefficient of x is 1, y is 1, z is 1. So I can write here the coefficients in the expansion is 1 plus 1 plus 1 to the power of 7, which is 3 to the power of 7. Okay. Another example is of similar type, x, y, z square. Find the coefficient of x, y, z square in this particular equation. 2x minus y minus z to the power of 4. So as you know, the general form of the given equation is n by n, n1, n2, n3, then x to the power of n1, y to the power of n2, z to the power of n3. So if you look at here, the n1 is 1, n2 is 1, n3 is 2. So 1, 1, 2, which is 4. So here I am going to get n is equal to 4, and which is same as this. So the general term will be given by this one, to the 2x to the power of 1 minus y to the power of 1 minus z to the power of 1. So if I find out 4 divided by this, this and this, what you are going to get is minus 24, because this value you are going to get it if you simplify here, 2x, so this will be minus value, so minus. Okay, so this value 4 factorial, that you are going to get it as 24, and this 2 factorial is 2, so this you will going to get it as 12, and here it is 2 into this is plus 1, that is 2 into 1, and again this is minus 1, so 2 into minus, so 2, which is equal to minus 24. Okay, one last problem on this particular topic will be this one. Find the coefficient of this one. If you find this particular problem, 8 is the total value, and n1 is same here, 3, 2, 1, 2. You are going to get a is 3, b is 2, c is 1, d is 2. So in this, so 2a to the power of n1 minus b to the power of n2, so 3c to the power of n3 minus 2d to the power of n3, and this n, whatever value is there, which is same as this n. So with this, if you substitute these values, 8, 3, 2, 1, 2, and again I have substituted all these values here. So 8 divided, and this is given by, so a cube, okay, so minus b whole square, then c, that is 3 into c, I have taken here c, and this is d square, and the coefficient of this, what I have taken is this value, okay, that is 2 to the power of 3 b square, then 3 to the power of 1 is 3, then 2 minus 2 whole square is 4, this one, and if you look at this, you will get a cube, this b square, then c, and this is d square, so minus b whole square is b square. So this is what the value is. Now if you find out this, you are going to get 96, okay, and the remaining is 8, sorry, if you find out all these values, you are going to get 96, and this is the value, that is 8 factorial divided by 3 factorial into 2 factorial into 1 factorial into 2 factorial. So with this what we are going to get is the value, that is 161280, which is coefficient of this a cube b square c d square. Okay, one particular chapter which is left in this particular module is combination with repetitions. So if you look at the number of combinations of any distinct things and taken r at a time, with that with the possible repetition is n plus r minus 1 cr. But we know that ncr is equal to nc n minus r. We have seen these in the various properties of combinations. So thus we have n plus 1 cr, n plus 1 cr is equal to n plus r minus 1 c n plus r minus 1 minus r. So this is as per the definition. So n plus, I'll consider this as n, okay, and this will I will consider it as r. Applying this particular formula, this one n plus r minus 1 c, this instead of n it is n plus r minus 1. So here as n minus r, so instead of r I have written n minus r here. So what I am getting here is n plus r minus 1. So this r gets cancelled. I left out with n minus 1. Okay, now I have given taken some of the examples how to use these combinations with the different repetitions. If you take one example, r is things, there are three different things, a comma b comma c, and the different combinations, when you take two elements at a time, then it would be either ab or bc or ac. So totally there are three number of options. So if you look at this, there are n numbers, that is n, r is equal to 3. So out of three elements I am taking two at a time. So which is equal to the same formula. If I apply this particular formula here, c is equal to 3 2 or c is equal to 3 1. In both the cases I am going to get n is ncr is equal to 3. Okay, so if I look at this is also 3 and here also I am getting 3. But here when you take with repetition, so it is n is equal to 3 and r is equal to 2. So AB, okay, BC, AC, AA, BB, CC. So here it is, say 6. So now if you apply the formula of nc of n plus r minus 1 comma r, which is the formula, if you apply here, n is equal to 3, r is equal to 2 and minus 1, and r is equal to 2. If you substitute these values, 3 plus 2 minus 1, which is 4, that you are going to get it as say 6. So this is what without with repetition. Okay, so now if you look at a b c d and 3 at a time, if you find out ABC, ABD, BCD, CDA. So there is no repetition at all. So in this case, I am going to get, that is 4. And if you find this also, this particular values, you are going to get it as say 4. That is C is equal to 4 3 or 4 1, applying this particular formula. So now with repetition, ABC, ABD, BCD, CDA, AAB, because here the repetition of letter A, AAC, AAD, so BAA, BBC, BBD, all these different combinations I am going to get. So where in which if I count here, there are 20. And if I find out n is equal to 4 and r is equal to 3, So that is 7. 7 minus 1 is equal to 6. So 6C3, I'm going to get this equal to say 20. So this is how we are going to find out the problems with the repetition of various combinations. So one such problem I am going to solve now. So in how many ways can 20 identical coins be distributed among 5 children? If there is no restriction, each child gets at least one time, oldest child gets at least 2 coins. If you look at this, there is a repetition because I have 10 different coins, but only there are 5 members. Even if I give one coin to each, I left out with another 5 different coins where I need to give that particular coin to the same old people. That is, a repetition will occur here. If you look at in the first case, 10 identical coins is to be distributed among 5 children. So with this, 10 identical coins are to be distributed among 5. So n is equal to 5. Out of these 5 people, I have to distribute 10 different coins. So r is equal to 10. So the required number of ways is given by n plus r minus 1 cr. That is 10 plus 5 minus 1 c5, which is 14c5, that is 1001. So if you look at another problem where each child gets at least one time. So first what I need to do is I have to distribute one coin to each child. Okay, with this I have left out with 5 different coins for distribution. So these 5 distributions, okay, so how it will be done? If you look at n plus r minus 1 cr. So initially if you look at r is equal to 5 here, remaining is how much? 5. So n is equal to 5, r is equal to 5. Okay, so I left out with what? Minus 1. So 5 plus 5 minus 1, so that is 9c5 is equal to, same applied formula, 9c4, which is 126. And last one, where the oldest child will get at least 2 coins. So that means what? We have to give 2 coins to the oldest child. Okay, so then I have left out with another 8 coins, which I have to distribute n is equal, among 5 children. So with this r is equal to 8, then sorry, n is equal, r is equal to 8 and n is equal to it is 5, n is equal to 5. So 5 r is equal to 8. Okay, so 8, this n is equal to 5, r is equal to 8 minus 1, that is 13. 13c8, which is same as 12c4. So applying the particular formula, what is that? ncr is equal to nc n minus r. That particular formula I have applied here. So here 12c4, with this I am going to get 495, which is my uh, uh, number, or these many number of ways where a particular child can get, the oldest child gets at least 2 coins. We'll see one more problem. Find the number of ways in which 8 shirts and 4 sweaters are to be distributed among 5 selected old people in an old age home, such that each one gets at least one shirt. So first of all, let us suppose that one shirt is given to all the 5 people. Okay, so in that case what will happen? We are left out with 3 shirts for the distribution among 5 people. Okay, so R is equal to how much? 3 shades, remaining 3 shades, and these 3 5 I need to n is share among different 5 people. So with this n plus r minus 1 cr, I am getting 7c3, which is equal to 35. Second option is 4 sweaters to be distributed among 5 people. So what happened? R is equal to 4 and n is equal to 5. So if I apply formula here, n plus r minus 1 cr is equal to n is 5 plus r is 4 minus 1. So 8c4, which is equal to 70. But the total required number of ways is both this and this. So hence 35 into 70 is equal to 2450. So these many number of possible ways where the 4 shades, 8 shades and 4 shades can be distributed such that each one gets at least one shade. Okay, one last problem. In how many ways can distribute 8 identical marbles? So this is important. Identical marbles in 4 distinct containers. Okay, you have 4 different containers and you have 8 identical marbles you are supposed to put it on. So no container should be empty, and the fourth container has an odd number of marbles in it. Okay, so now we are going to solve this. We have to put first one marble in each container because no container should be empty. So at least one should be there. Then later you can add few more uh, marbles into it. So now when we put all these 4, so remaining marbles will be 4. Okay, so now these 4 marbles I can distribute with all these remaining n containers. So n is equal to 4 and r is equal to 4. So if you do this, n plus r minus 1 cr, which is equal to 7cr, which is equal to 35, 7c4, which is equal to 35. So without a container being empty, options will be 35. So next is the fourth container can contain either 1 or 3 or 5 or 7 marbles because it is telling odd number of marbles. So this one is can be given in 4 different options. Okay, we'll see in this particular table how we are going to do this. If you look at the number of marbles in the fourth container to be at least 1. So these 8 containers is to be distributed among 3 different containers. Okay, so 7 marbles among 7 containers. So remaining 3. Okay, if I put 1 in the fourth container, what would be the distribution among remaining 3 containers? So that is here n is equal to 3, then r is equal to 7. So remaining 7 marbles to be distributed among these n is equal to 3. If we apply this particular formula, so it is 36 is one option. So another thing is when n is equal to 3, that is if the last container contains third one. So we are left out with 5 different marbles, and these I need to distribute it among 3 different containers. So that is n and r is equal to 5. If you now substitute this in this, n is equal to 3, r is equal to 5, 5 plus 3 is 8, 8 minus 1, that is 7, 7c5, and this one is also 7c2, which is nc n minus r. So ncr is equal to nc n minus r, which holds good here also. Again I am getting here it has 21. So it is in the case r is equal to 3. So now similarly when r is equal to 5, so I have left out with 3, I need to distribute it among 3. So which is n is equal to 3, r is equal to 3. Apply this particular formulas, you are going to get this I is 10. Okay, then the last one, I have to substitute. If I add all the 7 containers in the fourth one, I have left out with only one marble, which I need to distribute it among is equal to 3, R is equal to 1, which I got it as 3C1, which is equal to 3. Now, the number of ways which is required is this, and previous two, that is 36 plus 21 plus 10 plus 3, which is equal to 70.